Hey, good morning, everyone. My name is Mike Youthy. I work for Mueller Water Products and actually live in Montana, but cover the whole Northwest for what we call water management solutions. You'll see in this presentation today a little bit about what we do and what we cover. And really, what we're going to focus on here is non-revenue water. And it's a problem that we're all having to deal with. And as Oregon changes their regulations, we need to find ways that we can help reduce that number. And so today we'll talk about a couple different ways you can tackle that, leak detection being the largest part of this, but there'll be some other things in here. So hopefully we'll learn something today. I will be available for questions after this. This is being recorded about a week in advance. So if you have any questions, definitely get my information and reach out. So just a little background here. Think about, you look at our planet as a whole, about 3/4 of that is covered with water, right? But really, 98% of that water is in the oceans, and so it's not really water we can use for drinking or for irrigation. And so what we're down to is a couple percent that's fresh water, and really out of that, about 0.3% is what we think of as drinking water in our aquifers, in our rivers and lakes. The rest is frozen, and so when you think about, our planet's covered in water, what we're actually using for our drinking water systems is a very small. And then on the flip side, you look at how much we use. The United States, as a country, we use about 450 billion gallons of water a day. That number usually goes up in the summertime with irrigation, but we're usually around there on average. Only about 6% of that, 27 billion gallons, is used by us in the public water sector. The rest of that is in private. But if we look at the daily average of water that's pumped by that 6%, by those public water systems, that averages out to about 185 gallons per person per day. You think about, how much water you use on a typical basis. That seems like a lot of water, right? And it is. But part of that number is due to the total coming from everything. So what comes out through leaks is included in that number. And so this is what we're getting at with non-revenue water, is the amount that's actually being used versus the amount that we're producing. And there is a gap in there. So I like to put this cartoon in. You see these guys in a boardroom looking for new sources of water. So they're saying, well, why don't we desalinate or go melt some icebergs? And then you see the guy there with the cups of water saying, why don't we just plug the leaks? And it's a valid question because we're, dealing with these water systems that have been in the ground for 50, 100 years in some areas, and a lot of them are starting to just age and fall apart. And so if we can focus on rehabbing those systems and upgrading those systems rather than trying to find new water, just make the best use of what we have already. And so if we'll take a look at North American utilities, on average, as I said, our infrastructure is aging across the country, but our water loss can vary. And right now, Oregon is pushing for 10% or less non-revenue water numbers. And across the country, we're at about 10 to 30%. And in some areas, we've seen even as high as 70%. That's typically in areas where water is pretty cheap to come by and it's not as big of an issue. But you think about that number. I mean, imagine if Amazon were to ship out to their customers and 70% of that never made it to the end user. They wouldn't be in business. And so we need to get better on this, and we're going to talk about some ways we can do that. Drought conditions, something that definitely has had an impact here over the last month or so. And I like to put this in here. In 2012, the United States EPA did a distribution condition assessment report of all the countries throughout the world. And we actually ended up grading everyone and gave ourselves a D-. And that number is mostly due to the age of our infrastructure, but also just how we're taking care of it. And so that's something to keep in mind, is that we're, our own country, aware of where we're at with this. So real losses is something we're going to talk about today. And most people assume, especially the general public that doesn't work in this sector, that the largest volume of water that's lost is due to main bursts. That's, what they see in the news. That's what they see on TV, is that, this water line broke and we're losing all this water, and so that must be where we're losing water. In reality, those big main breaks, while they can be very costly, are not usually the main source of non-revenue water. In reality, those losses are due to the three things that I have listed out there. So background leakage, which that's leakage that is happening all the time. It's so small that you really can't get to it, but it's going to happen throughout your system. Then there's also unreported leaks and breaks, and so that's kind of where we get into leak detection and being proactive in finding those leaks before they become the big issues that we see on the news. There's also reported leaks that have been running. The utility knows they're there. They just haven't gotten around to fixing them, either due to cost or just time. And so that's really the main categories of real losses. And non-revenue water, I want to make sure you guys are aware of this. It's really, there's three components. Real losses that I just covered is the one that we're going to look at today. There are two other areas that fall into non-revenue water, and depending what you're trying to do, you can take a look at these other areas as well. So one of those is unbilled authorized consumption, and so you can think of this as like your state parks. It's areas that are using your water supply, but they're not actually paying for it. As long as you know about that, that really isn't too big of an issue. There's also apparent losses. This is another big category to look at. We just don't have time today, but this is going to be unauthorized consumption, so people actually stealing water. This is also going to be meter error, and so something that does get discussed a lot when you look at non-revenue water is the meters, and are the meters reading accurately? How much water is actually going out through these meters? And so that's something else you can look at. But today, like I point out there, apparent losses should be pretty low in your pressure systems as long as you have a pretty good idea of what's out there. And so if we just focus on the real losses, so how do we control that? We're going to look at four main areas today, and you can see them there on that picture on the right. So inside of those arrows, you've got a box, and so we've got our current annual real losses is the largest box. We've got an economic level of real loss inside of that, and then there's an unavoidable real loss inside of that. And so that unavoidable real loss, it's just a value that it's going to always exist. There's going to be water losses in there that are not technically recoverable. There's also going to be losses in there in that second box that doesn't make sense financially to try to go out and fix those. But that largest box is the economically recoverable losses. That's really what we want to focus on. And so we're going to look at four different ways we can do that. First, speed and quality repairs. I'm just going to briefly kind of go through some things to look for when you're looking for couplers and repair couplings, because that's something that you guys probably all have on the shelf. And when you go down in there and try to fix something, there's a few things that can make that a quicker, easier process for you. And so we'll look at that briefly. Then we'll look at pressure management. And so we're going to talk about, you can see that arrow goes in and out. And so as pressure goes up and down, your actual water loss can go up and down as well. So that one can actually add to your non-revenue water if you aren't careful. And so we'll look at some ways to do some pressure management. Then we're going to look at just a real big overview of asset management, what that process looks like. Some utilities at this point have whole asset management groups, or at least a person that's focused on that. Some smaller utilities are just getting started in this process. And so that's where I spend a lot of my time throughout the year. And so I'll give you kind of a brief overview of what Mueller's doing on that side and what you guys can start to do in your system. And then lastly, we'll look at leakage control. It's, depending what you've got as far as instruments or equipment, if you have someone come do that for you, it's there's a whole bunch of different ways to look at leakage control. And so we'll finish with that. All right. So as I mentioned, we are going to start with what Hymax is Mueller's brand of couplers, and these points that I'm going to make here are really, you can look at them for any kind of coupler. So why do we repair pipe? Well, we talked about earlier that sometimes you have reported leaks that you haven't gotten around to fixing, so that's going to add your non-revenue water number. but also it's going to improve your operational efficiency. Your actual costs of running that water system are going to decrease if you fix the leaks. Reduce potential for contamination. So that's one we don't always think about when we're fixing leaks, but the sooner you get that fixed, the less likely you're going to have something come in from the ground and contaminate the water, lead to boil water advisories, all these things we don't want. You can actually extend the life by fixing these earlier. Reducing property damage. As you guys know, when a leak starts, the longer that goes on, more chances for things to get catastrophic. Water outage events, we never want those. And really what all this feeds back into, from non-urban water side as well, is public relations. You know, we run these water systems, we feed our communities, and having good PR is really doesn't have enough focus, I think, for a lot of water systems, because this is what they're drinking out of their faucets. And so if you can have good PR, it's just going to make your job that much better. So on the coupler side, we're looking at different gaskets you can use. One thing to look out for when you guys are picking out your couplers is pressure assisted gaskets. So as I say, not all gaskets are created equal. Look for these products that are going to work harder for you by just being smart. And so you can see in that image there, pressure assisted gasket, all that is that water pressure that's inside of your pipe is going to actually help seal that gasket. So yeah, you've got your bolts on the outside that you hook this thing on there. And once it's in there, the pressure from your water is actually going to help keep that thing sealed. And so you're less likely to have to go back in there and fix this at a later time. So definitely look for pressure assisted gaskets when you're picking out your restraint couplings. Also, depending on the type of pipe you're trying to fix, look at the restraint systems that you're using. So a lot of the older ones have just point loading. So, you know, you've just got one little piece that's holding a rim around there. Look for something with these wedges, like I've got the pictures there. Gripping systems that have those actual wedges on there that have, you know, little grips, that's going to keep your pipe together, and it's going to also help prevent the pipe from pulling out. You know, that's what we want to avoid here. We want to go in there, fix this break, and never have to worry about it again. And so if you can get something with a larger grip, that's going to help you from having your pipe angularly pull out of the ground. Also, when you're looking for these, something to spec out, dynamic deflection. So all the products that are out on the market should have, I mean, whether it be Romac or Hymax or whoever you're using, should have a degrees of deflection that are allowed once you put that coupler on there. And that's going to be your cushion for anything that happens down the road, like ground movement, or if you've got, you know, some kind of surge in your pipe or something happening on your joints. So look for that, look for your degrees of deflection, and then, you know, make a decision on what couplings you're going to buy based on that, because that is your cushion that's allowed. Also, something to think about here is the materials that are used. So I put molecular anti-galling, which is MagTech, if you've heard of that. All that is we're just looking at better materials that aren't going to seize up. So you can actually reuse these. You can actually take that bolt off once it's in the ground. So look for things like zinc impregnation. Look for anything that's not going to have, you know, the dissimilar metals that are going to fuse together. So that's something else to look for corrosion and for being able to reuse these. And really, the big one I want to point out here is two-in-one products. There's a bunch of different couplers out on the market now that can be used as a wraparound clamp or as a coupling. So that's going to give you guys smaller inventories. You have one product that you can use for two different ways. And along with that, there's also couplers now that cover size ranges. So it'll fit a 3, 4, or 6-inch pipe. You imagine you have 10 of those on the shelf for all of those pipe ranges. It's just going to also reduce your inventory, spend less money on parts, and just have them ready to go for when a break does occur. And all of this is down to, you know, getting in and out of the trench faster, being able to fix these leaks as quickly as we can. And I also point out again, corrosion resistant materials. Stainless steel is a lot cheaper than it used to be, and it lasts a long time. And, you know, we talked about dissimilar metals. One other thing I did want to mention is look for those couplers that have bolt holders on them. Seems like a small thing unless you ever been down in a hole and tried to put these couplers on as water spraying out and you drop a bolt. So there's a lot of newer couplers now that actually the bolt can't really fall out. So look for that as well. So that was just kind of a quick, things you can think about if you're going to spec new couplers, things you can keep on the shelf. So now we're going to look at non-revenue water from another angle. So that was a real basic, just getting out there and fixing leaks as soon as you can, right? We should all be doing that. So now we're going to look at pressure management. And as I mentioned on that first, box with the arrows, is that you can actually increase or decrease your non-revenue water number by controlling pressures. So we'll start with this. This is real basically what's going on in your system. So dynamically on that top picture, as your customers are using water, you're going to see a pressure drop because it's being used. No one's using that water, that same pipeline is going to see a static pressure increase. And why do we mention this? Well, a lot of times people are saying, well, my pipes tend to break in the middle of the night. I don't get why that is. This is why that's happening. Is you have less demand on your system. If you're still using the same pressure coming out of your pumps, all of those pipes are now dealing with a higher pressure than they were used to for the whole day, and that's typically when we see breaks. And so if we can lower our pressures, that is going to potentially lower our breaks. Seems straightforward, right? Like I said on the last side, break frequencies are generally higher at nighttime, not just nighttime, but off peak. So whenever we're not having a bunch of pull, so middle of the afternoon, I guess prior to COVID, now all day long you're probably getting water usage, but usually middle of the nights when things change from dynamic to static. And another thing here, pipe breaks mean leaks, but also the cost of repairs. You think about what we were just talking about, going down in the hole and fixing that, how much of that time it's going to take and money it's going to take. So if you can just keep one break from happening. And so I mentioned at the beginning that there's really 3 types of leakage that go into our real losses. And so you can see on the left, we got our background leakage. That's the real small stuff. It's undetectable using traditional leak detection. It's also unreported. We don't know where it's at. There's unreported leakage that we can detect. And so that's that middle section. It really requires going out and doing some leak detection and finding that. Then there's reported leaks. These are the ones we already know about, and we just need to get in there and fix. And why I'm mentioning this again is if you look at the bottom, ways that you can reduce all 3 comes down to pressure stabilization, pressure reduction, and proactive leak detection. And so that's really what we're going to talk about today. First, we're going to look at this, how do you reduce your pressure, and what is that going to do for you? Well, it's going to reduce the amount of water that's coming out of your leaks. And as I just said on the previous slide, it's also going to reduce the amount of breaks you have in the first place. So getting control of your pressures is going to be huge for non-revenue water. And then the other part is proactive leak detection. Instead of just waiting for a break to happen and then dealing with it, we can get out there and find these early. And so now this graph kind of can be confusing until you look at it. What we're showing there on the left is volume of leakage. That's just amount of water that's coming out of your leaks. And then you can see over time, which is on the x-axis there, that's going to go up. So you're going to lose more and more water. And then at those points at the top, that's when we go out and do some leak detection. We're going to find and fix everything we can. All right, we bring it back down, and then over time it starts to go up again. And that process will continue in your water system for the rest of time. And so what we're able to do with pressure control is 2 things. And so you can, by lowering your operating pressure, you can reduce the leakage volume. And so you can see that total amount, so you can see that minimum achieved leakage before pressure and after pressure, that total amount is going to go down if you can lower your pressure. And so you have a new baseline that's lower than it ever was before if you can drop your pressure. It's also going to decrease the amount of new breaks. And so you can see that, that peak that it keeps hitting is now spread out to a year rather than a half year on this little graph. And so this seems simple, but you think about, if I just lower my operating pressure a little bit, I can do 2 things. I can decrease the amount of water I'm already losing through leaks, and I can decrease the amount of breaks just by doing one thing, lowering my operating pressure. And the other thing to note is that unreported leakage, that background stuff, that's also going to be reduced. So at the end of the day, this is a huge way to tackle non-revenue water. And one of the main ways that we've been talking about doing this, I did a presentation similar to this at Seaside recently, and we talked about, it was OAWU, we talked about what is a DMA, how do we put these in our system, and really it's a lot simpler than people might think. If you don't have a DMA, it's just a district metered area. And what all it is it's giving you the ability to look at a smaller zone within your whole distribution network. So rather than saying at the treatment plant we had X amount of gallons produced and treated, and then this was how much went to customers, we can break that up into smaller sections. You can say, okay, now I've got in the Northwest, I've got this little chunk, and I can see how much water is going in and how much water is going to those customers. And all you need to set this up, two things: you need a meter and a PRV, or a pressure reducing valve. And so as long as you can control the pressure and measure the flow, and I will mention briefly in here, we can all do that all in one valve now. So a DMA doesn't have to be this big production. Just put in one valve where you can get a flow reading and control your pressure, and you now have a DMA. And so the meter is going to give you the ability to measure the flow into that area and compare it to the flow out. So instead of looking at, like I said, the treatment plant to the customers, you're now looking at flow into that DMA to those customers. We can also now tell which areas have the most leakage. So you can compare your DMAs and you can say, in this area I've got X amount of non-revenue water, and here I've got Y. So, you know, this is a good way to start tackling non-revenue water. If you're like, where do I start with this? Break your system up into smaller sections, and then you know where you can focus your time. So you adjust your PRV to save pressure in that area to the amount that you can. And this last point here, 1% reduction in pressure is going to give you about a 1.15% reduction in lost water. And so you think about that, just a couple percent of reducing your operating pressure, you're going to save a bunch of water. Actually more water than that pressure reduction if you're looking at just percent. And so here's a little image of someone that thinks, you know, images are a little easier to look at. So you got a treatment plant up at the top. It's going through that green meter. That green meter is your main production meter. That's how much water am I producing every day. It's going out to some reservoirs there. And then you can see those blue meters are your actual DMAs. And so now, instead of just green meter to customers, we're going blue meters out to customers. And so now we can look at those 4 orange squares and say, where do we have the most amount of non-revenue water? That's where we should spend our time looking for leaks. So maybe we've got someone that's stealing water there. We can start looking at this in a lot simpler format than just, we have 20% non-revenue water, we have no idea where it's going. And on this screen, you can also see, I was talking about the percents on the last slide. We turn that into pressures. A 10 psi reduction of your overall max pressure is going to give you about a 6% change in your water loss reduction. As you can see, as you can get more pressure reduction, you can save more and more water. And so this is a great way to start tackling and getting after your non-revenue water and decreasing that, is with flow-based pressure. And so here's the DMA. It's what it looks like. Typical installation. So this is with a flow meter. So you can see you got a mag meter on the far end of that. You've got a couple of PRVs, small bypass, some strainers. Really not a whole lot to this. You put this down in the ground, you now have a DMA. And there's going to be some classes, I believe, either later today or tomorrow on control valves. So definitely check those out. I won't spend time talking about how these work today. But I do want to mention that pressure reducing valve, if you're going to put one in, make sure that you've got about 10 psi differential. For these things to work really well, you need to actually be able to reduce the pressure 10 psi or more. If you're just trying to reduce it 4 or 5 psi, it's going to be really difficult for this valve to operate. PRV, if you don't have one, all that is a valve that's capable of keeping a set downstream pressure no matter what's coming in your upstream side. Some of you guys don't have them, but I'm sure a few know what these are. What happens if that valve fails though? So say we are using a PRV, you've got 60 psi downstream all the time, you got 100 psi coming in the upstream side. Well, what happens if that valve were to fail? What we've come out with now at Singer, which is Mueller brand, is a PRSM valve. Hillsboro, Oregon is pretty much standardized on these. If you guys have questions about these, definitely reach out. They're super cool valve. And what really all that they're doing differently compared to a normal PRV is you have a backup built in. So you can see on that picture, you've got your chamber on the bottom, and that's connected to a pilot, and that's set for a certain pressure. And then you've got a chamber above that, and that's actually set up for a slightly higher pressure. And so if your main body ever fails, so if you get your strainer clogged up or that diaphragm were to burst, something were to happen, rather than ending up with high pressure coming through that valve, it'll automatically switch to that backup, and that backup is going to take control. And so you now can put in redundant protection, especially in areas that you just really can't afford one of these to fail. Those exist. Something else you can do with PRVs, and something that I've seen a lot of more utilities doing, there's a couple different ways to do it. And so the first one here is just time-based. We talked about at the beginning how dynamic versus static. So at nighttime, you have that static pressure, you have really low flows, not a lot of demand. That's when your breaks occur. So what if we reduce our pressure just at nighttime? And so one way to do that is what I have shown here. You've just got a solenoid and two different pressure settings, two different pilots, and it's just time-based. And you can do this, just with a little Rainbird timer, or you can actually hook it into SCADA and change it when you want to. But what you're able to do then is say, all right, it's nighttime, we don't have as much flow. Let's change it to our lower pressure setting because we don't need that much pressure. We just don't have that much demand. So you can save pressure for 6-8 hours a day, help prevent breaks, help the amount of leaks that's happening at night. Another way to do this, and really the way that I would push you guys if you are going to look at this, is a totally hydraulic options. There's no electronics involved in this, but same thing as the last slide. You've got two pressure pilots. You've got a higher pressure and a lower pressure, and then you've got that little blue thing, number 7, if you're looking at this schematic. And what that is a differential pilot. And so that's going to look at, you've got an orifice plate in this, and so it's able to tell, all right, we've got a lot of flow, let's stay on our high pressure setting. Now the flow goes down, demand decreases, say it's the middle of the night. That differential pilot's reading across the orifice plate, and it's going to say, okay, we don't have as much flow, we don't need to have as high pressure. It's going to switch to your lower pressure setting, and then it'll switch back when you get more demand. And so this can run back and forth, increasing and decreasing pressure, and helping you save water when you don't need it. So great idea. You can retro this into whatever valve you got. If you got, clay valves, Burmads, Watts, whatever you got, you can retro this in. Or if you're looking at a new valve, definitely think about this. It's all hydraulic. Good way to save water. And then you can see there my personal favorite valve. It's that dual chamber, so it's got the redundant backup as well as the 2-step pressure for night and daytime flows. Great valve, totally hydraulic, does everything you'd ever need it to do. And then, that's the hydraulic way to do it. If you've got electronics, if you want to run SCADA into your vaults and have more ability to control and see what's going on, there are a bunch of options for that now. So you can see what we've got on that pilot in the picture is a little motor actuator. And so Clayval has something similar. This is Singer's is called a 420 DC. So you can run this off AC or DC power, so you can put a solar panel up, run this if you want. And it's got a little motor in there. You imagine instead of a guy going in and turning that pilot setting with his fingers, you can remotely from your desk say, all right, we don't have much demand, let's decrease the amount of pressure, and you can have that motor actuator slowly decrease the setting. And then you can bring it back up. It just gives you the ability to remotely change your pressure settings. We can also do this with solenoids. So if you do this dual solenoid control on a valve, you can run this however you want. So you can hook this up directly to a flow meter. You can hook it up to pressure and flow, hook it up to level. By using this setup, you can make your valve do anything you want it to. In the results of a power failure, you can do backup hydraulics. That's what I would normally recommend. And all I'm really getting at here is there's a ton of ways that you can take control valves, which people think of as, oh, it just reduces pressure from X to Y. You can have it do a whole bunch more than that. And one of the newest things we can do now is actually meter in the valve. So I mentioned at the beginning what a DMA is. So a DMA has a pressure reducing valve and a DMA has a flow meter. Now with this, what I'm showing on the screen here, it's a micrometer product that we use, but that's just an insertion meter that's built into the body of the valve, and we can put it on anything 3 to 48 inch size valves. So now you've got your pressure reducing functionality and your flow metering all built into one valve. You can put in a DMA in the space of a couple of feet. It's enough on pressure management. We're about halfway through, and now I really want to focus on the leak detection side of this, asset management, and what this all comes down to is Mueller acquired a company about 10 years ago called Ecologics. So if you're not familiar with them, definitely check out the website, see what we have to offer. The rest of what I'll be talking about here is really in that realm of the business. And so we're going to start out with looking at right now, how do we decide what water lines we replace? Well, typically failures. The pipe failed, we should probably replace it, right? Maybe all these pipes are 100 years old. Maybe we should replace those pipes. Maybe it's a certain type of pipe. You've got a certain class of ductile that seems to fail, a lot more often than others. Let's replace those. Maybe it's capacity. You just need more for fire flows. You need to upgrade these pipes. Fiscal limits. Budget is always a big part of these decision-making processes, and government mandates can be a part of it too. But really what I'm getting at is what we're doing right now throughout the country for most of how we rehab and replace water pipe is just guesswork. We're just making our most educated guesses that we can, and there's better ways to do it. And so that's really what Ecologics focuses on as a company. And so you can see what I've got up here is what we call our condition assessment pyramid. And what you can think of this at is the very top level is going to be your cheapest option. Very bottom level of that pyramid is your most expensive option. But we're trying to kind of funnel down and figure out what to do. Where you can see at the bottom, do we replace? Do we rehab it? Do we just repair it? Do we defer? Do we just wait? Or do we monitor, which we'll talk about a little bit, what EchoShore is, and that's our leak detection. And so what do you do? And that's the next step after the pyramid is which of those options to choose. But in order to choose that option correctly, you got to look at what's in that pyramid there. And so pipe rank, I'll briefly mention what that is. There's a few others out on the market. It's virtual assessment. And so what it does is takes all that guesswork on the previous slide and using actual algorithms and AI helps make those decisions with you and for you. Then there's survey level inspection. We'll talk a little bit about ePulse, what that is. And it's just going out there and taking some actual data on your pipes and getting an idea of how worn out these pipes are. And so that survey level is going to be your cheapest way to hit a lot of area at once. Then there's non-destructive inspection, but this is going to be stuff you put inside the pipe. We won't really look at this today, but there's electromagnetic technologies. There's different, you might have heard of like smart ball. There's things you can put inside your pipeline. Usually you have to shut down to do this, but you can do some really good testing with that. All the way down to material. I mean, you can take actual samples of your pipe, but as you can imagine, that is not cost effective. And so really that's just an overview. What pipe rank is, it's our version. You may have heard of like Fracta, Voda, there's different ones out there, but what we're trying to do is find the most high-risk pipe for you. And so rather than doing all this guesswork and saying maybe we should replace the pipe in this neighborhood because it seems worn out, the program is going to take all of the data that you give it, and it's really a screening tool, and it's going to give you the option to kind of move to the next phase, which we'll talk about all these today. ePulse, which is a diagnostic measure, it's condition assessment, actually collecting data. Then there's EchoShore, which is more the monitoring side. So rather than just taking measurements, what if we do something about it? What if we actually monitor this area for leaks? And so first we're going to talk about the pipeline condition assessment. So Mueller, what we call Ecologics' side of it is ePulse. There's a couple of different options out there to do this. It's acoustic measurements, and you're analyzing the sound waves to determine what wall thickness you have left. And so you can do this in asbestos cement, cast iron, ductile iron, really any kind of metal pipe. It also works on concrete cylinder. You got big transmission mains. And what we're going to do is take correlation that you may have seen correlators used for leak detection. We can use that sound wave collected with the correlator and give you an actual measurement of your wall thickness. Best part about this technology, you saw it was cheaper up on that pyramid, and that's because it's non-intrusive. You're not actually going in there. It's non-disruptive. So you can be running your system as normal and on the surface collect these measurements. And why do we do it? We kind of already went through this, but we can get an idea of what's happening today, which pipes are most likely to fail, and then what do we do about it? How much time to fix it? So you can see here we got pipe 1 and pipe 2. They're both put in 1860. They're both in similar soil, got similar corrosivity, both 6-inch cast iron. Well, what do we do about that? And this is kind of where a lot of utilities are at right now is, do I replace this pipe? It's 100 and some years old. Well, we pulled these pipes out of the ground. This is from an actual example. The one on the left was shot. Pipe 2, almost perfect condition. E-pulse measurements, and this was actually a validation of our technology when we did this, we came up with 31% thickness loss on that pipe. We had 1% on this pipe. Without pulling these out of the ground or without doing e-pulse, there's no way to tell that that was the case. And so, why is this technology important? Well, you may start to get the picture here, is that your pipe's underground. We don't really know. And really the issue that we're trying to tackle with this is that across the country right now, about 64% of pipes that are pulled out of the ground were still in good condition. They didn't need to be replaced. They had another 20 years of life left. And so we're trying to prevent that because pipe replacement, as you know, is really expensive. Depending, where you're at, if you're in a busy Main Street area, it can be $1 million to replace a mile of pipe. So we don't want to do that until we really need to do that. And so this is where leak correlation comes in. So we're going to talk a little bit here about how just a basic correlator works. If you guys are looking for ways to go find leaks, I would definitely recommend a correlator. They've been around for a few years. The technology's gotten really good. And what these are is you're going to try to bracket the leak. So you can see in that picture, you've got a leak happening. You know it's somewhere between these two hydrants, or at least you think it is. And you're going to hook up your two sensors. You've got sensor 1 and sensor 2 hooked up to those two hydrants, and you're going to get around that leak. So now what you're going to have to input is the length. So you can wheel it off or look at a map. How long is it between 1 and 2? So you input that. What type of pipe is it? You need to know that. And then diameter of the pipe. So you need those 3 things. You input those 3 things. You hook up your 2 sensor connections. And now it's going to do the rest. It's going to listen, and as that noise from the leak travels in both directions, it's going to pick it up at number 2 first before it picks it up at 1, and it'll keep listening for a few minutes, start ignoring background noise, and it's going to be able to tell you exactly where that sound is coming from. It's back calculating the speed of sound and giving you a distance. So as long as you know what type of pipe you got and how big it is, you can find out exactly where that leak noise is coming from. Usually the screen is going to look something like that in the bottom right. And if you look at our technology, I always carry mine with me. I can do a demo. It's pretty fun to go out there and use it because it really has gotten so much simpler to use. Rather than hiring a company to do it, I would definitely recommend purchasing your own. You can hook these up a couple of different ways. You see there we've got hooking with a magnet directly to the pipe. That top one, we've got a pothole down to the pipe. We've got a connection point that's threaded for hydrants. You can see it on the left side of that hydrant there. You can see that threaded connection. You can also hook up to an air leaf. Really anywhere that you can put a 2.5-inch thread connection, that's an option, or the magnet. But you hook up your 2 connection points, input the type of pipe, and it'll tell you. So now I mentioned e-pulse in this condition assessment and trying to figure out how old the pipes are from the surface. So how we do that is the exact same technology. We take our leak finder, and it's the correlator, and we go out there, But this time there's not a leak happening. Well, if there is a leak happening, we'll find it. But if there's not a leak happening, we make a noise. You see, we're making a noise on that hydrant on the right-hand side. As the sound travels through that hydrant, so usually what we'll do in the field is tap that hydrant with a hammer. Sometimes you flow water out of it. You get a noise that's consistent, that's coming through the pipe, and it's going to pick it up at our two sensors. And now this time, we're actually going to calculate the velocity. So we're going to say this is how fast sound's traveling. What we're able to do with that is compare it to what brand new pipe should be. We know how fast sound travels through this material pipe that's this size. It's actually traveling at this speed now, and so something has changed. Well, what's actually changed is the wall thickness. And so we're getting a measurement of the structural wall thickness of this pipe, and it's going to be an average across each chunk that we're testing. So real simply, on the left, you can see the wall is decreased. We're going to have a slower speed. Brand new pipe on the right, it's going to be a faster sound. And so as pipes wear out, they allow that sound wave to slow down. And so you can see here, we're not actually getting that minimum circumference. That's more for the technologies that go inside the pipe, the electromagnetics. We're getting an average. So we'll hook up sensor 1, sensor 2, and between that connection point, we can tell you an average wall loss. And so you see on the bottom there, that's the number we're providing. It's going to be on the left, a 0.18, on the right, 0.27. You can see on the left, there's a lot more wall that's gone, so that wall thickness is going to be a lot less. On both examples, we do have one pit that's 0.13. That's not what this technology is for. This technology is giving you that average across each section, and what we're able to do is hit about a half. So you can see this is how we go through a system. We've got our connection point in the close frame with those 3 cones, and there's one down at the end of the street. We hook up our 2 connections, and then we got a guy over here on the right-hand side that's spraying water on that hydrant. So he's making the noise. We're picking up the noise at those 2 locations. And then we've got a guy, he's in the back of the car on the computer, and he's saving all these audio files. And then we're going to take all that back and write up. And this is what you get. So this is the final result of doing ePulse. As we go around, you can see we hit all these different pipe segments, about a half mile a day. So over the course of a week, you hit a couple miles of pipe. Hit different areas, different neighborhoods. Maybe it's your most critical areas. And what we're going to give you is those, the last 4 columns there. But really, what's important is those 2 lit up ones. You've got a percent change of wall thickness. So you can see we went from 10.9 millimeters to 9.1 millimeters on that first pipe. So we got 17% loss. And what that equates to in that type of pipe, you still got 50 or more years. So don't worry about that piece of pipe. Where you should really be worried about is that next segment down. Should be 10.9 millimeters. We measured 4.4. So you can see we've got 60% of that pipe wall is gone. It's exceeded its remaining service life. That pipe, as you can see on the far right column, 3% chance it's going to break this year. And so this is really what we're trying to do with this technology, is give you guys a picture of, which pipes are shot, which pipes should we be spending our time looking at, and which pipes can you ignore and just defer and leave alone. The last part of this that we're going to talk about today is active leakage control. And so, as you know, you can purchase a correlator, you can have a company come do that. This is a little different. So what this is, and you might have seen on that pipe rank screen where I had one option is ePulse, which is what we just covered, where you can go through, find out wall thickness measurements. Another option is Echo. So this is Echo Shore. It's the ability to monitor your pipe in real time, so we can catch a leak when it looks like that, instead of when it's blowing up the street and causing massive destruction and costly amounts of money for your utility. And so how do we do it? So Mueller has 2 options that are out on the market now. We have DX, you see on the left, and TX on the right. So DX is actually something we can put on the hydrant and allow your hydrants to be constantly looking for leaks for you. So instead of going out with a correlator, hooking up, or going out with those loggers that you leave over the weekend, you can have these things 24/7 looking for leaks. Same thing on the right. It's just a different setup. It's made for transmission mains where you don't have hydrants, so it's just threaded connections that you can hook up down a pipe. What are we trying to do with this? We're not trying to give you, like on the bottom there, just a bunch more data. You've already got a bunch of data in your water systems. Everyone's trying to sell data these days. We're trying to give you an insight, an actual point of interest, an area where you've got a leak occurring. And what it looks like is not just a bunch of sound that it's picking up in your system. It's not even just the heat map of where there's the most sound. It's actual locations that you've got a leak happening. So how does that look? So what this system is going to do, you say you put out the DX system, you cover 50 hydrants with these. So every night from 2 to 4 in the morning, all of these hydrants are going to kick online, and they're going to listen, the same way that the correlator does. So they're going to listen, they're going to know what types of pipe, they're going to know how fast sound should travel. If they're hearing a noise that's consistent, well, you can see on the left there, they heard 30,000 noises overnight. Okay, that's not helpful, but they were listening, and you can listen to those audio files if you want. Then they are looking for just persistent noises. So they're looking for noises that are happening at the same frequency from the same spot, and they're consistently there. So after a couple of nights, it's still there, and it's actually getting worse. It's not getting better. Okay, that's a leak, and that's how we get to that image on the right of actual points of interest, recommended locations to go look. Sunrise Water in Happy Valley, Oregon actually has one of these systems. If you want to look at someone that implemented this, we've got a few others in the area that are starting to look at putting these in. And so all these are, you're going to replace your pumper nozzle on your hydrant with what we call a node. It's going to look exactly the same. We'll paint it the same color as your hydrant. We will make sure the threads match, so it doesn't have to be a Mueller fire hydrant. We make your threads match, and we replace the pumper nozzle with this smart pumper nozzle. And it's actually a leak monitoring node. And so all of these nodes are going to listen, they're going to collect that audio data, and then they're going to send it out through cellular, so either Verizon or AT&T. They're going to send it back to our servers, and then you are going to have access to a user interface. And so it's a web-based interface. You log in, and we're actually pulling everything back to this now. We call it Centrix. And so if you've got any of our flushing products or anything that's really hooked up to technology, you can pull it up on Centrix. But you see, you can go in there and you can see overnight, it'll give you, what are your actionable items? Is there any? So sometimes you come in the morning, nothing's there. Okay, good, we're good to go. Sometimes you come in, it says, all right, we got a point of interest. It'll give you an actual GPS location where it is saying you've got a leak happening. And these leaks are going to be, 2 to 5 gallons a minute. This leak just started. Get out there and fix it now before it's a problem. And so this is what we're trying to do with this Echo. Here's a little bit of a picture of what that cap looks like. You can see on the left, we've got a red one. On the right, you got a white one. And really, the only difference you're going to be able to tell is that they're a little wider than a typical pumper nozzle. So you look at that center picture. There, you've got 3 screws. So if you ever got to replace the battery, it's got about a 10-year battery. But when you do have to replace that battery, you just pull out those 3 screws and replace that center puck. So that center puck is a composite material. It's real sturdy, and it's fireman proof. And built into that is the actual audio microphone listening device. It's got your GPS, so it knows which hydrant it's on. It's got your battery, obviously, and it's got the cell, the ability to call out and send this through Verizon or AT&T, send out its file. And so you can set up different areas. So you can see in this example, we've got our standard monitoring. So that's every night it's going to listen to those hydrants. And after a few nights, if it's hearing the same noise, it's going to say you've got a problem. Critical monitoring, we can actually have these things check every hour. If it's an area you're really worried about, you can't afford to have a leak, you can have these things monitoring more often. Only difference is you're going to kill the battery faster. You're going to be sending out a lot more data over the cell service. But this is what we're able to do with this technology. This was a quote guy at American Waters. He said it was a time bomb diffused. You can see the picture of when they pulled it out of the ground. And you can see on the bottom picture, you can barely tell it was even happening. When they pulled it out of the ground, there was a little crack on that bell joint, and the DX system had been kind of catching this, and you can see it grow on the correlation graph. Over a couple of weeks, they were saying, all right, this is a leak, you got to get out there. So they got out there, dug it up, they found that little crack, fixed it, and I mean, if they wouldn't have fixed that, it was in a real busy area, it would have been a mess. So that's what we're trying to do with this technology. And then the TX system, as I mentioned, if you don't have fire hydrants, as you can see, this is an above ground transmission main, but if you've got a transmission main where you don't really have fire hydrants on it, how do we monitor that? Well, we've got a different system. So it's, you can see probably best in that center bottom picture is that threaded connection on the air leaf valve. And so these we're going to thread on. We can add in a location, as you can see on the right. If you don't have any hookups, we can create one. And these are going to be hooked direct to your water, work the same as the other system. It's got battery, it's got cell, it's got GPS, and it's listening for leaks. Some advantages of this system, well, there's a few. One, this works on plastic, whereas the other DX system does not. This is because plastic pipe's a lot harder to hear. The breaks on plastic are a lot lower frequency. So we can find them using our correlator, but the DX nodes have to listen through a dry barrel fire hydrant, and so they're really made for metal or AC pipe. This system will work on plastic because we're actually hooked up to the water, and so they're really, really sensitive, listening to what's actually going on in the water. Other benefit here is you can spread these out. So these can be a half mile apart, whereas the DX nodes are about every block. And this is because some other benefits here, since we're listening to the water and touching the water, we can pull back any 4 to 20 signal you want. So while we're listening to leaks on this section of pipe, we can also be monitoring for pressure changes, for temperature changes, chlorine residuals, really anything you want. And so this gives you a full option for monitoring your pipeline. So definitely something to look at if you got, a lot of times I'll see this in areas where one city is selling to another on that section of pipe where you really couldn't afford to have a break. Monitor for breaks, but we can also watch for different, we can look for water hammer, we can look for chlorine. That's EchoShore. Last thing I'm going to leave you guys with today is our pressure monitoring systems. So potentially, you want to try to catch leaks in your system early, but this acoustic leak detection just seems like more than you really need. We do also have these remote pressure monitors. So you can see on the left picture, that's what they look like. They're a little black box that they can fit into a valve box. So you can see that picture on the right. That's one way you can use these, is drop them into a valve box. They're actually traffic rated and you can lock them in there. And then you can see it's got a little wire there that's hooked into the water main. So it's just tapped into the main. Once you hook these things up to your water, they're going to start giving you a pressure signal. And so that pressure monitoring is going to be 24/7. And so you can, there's different ways there's 4 different modes you can run it in. So you can do steady state or transient state. Steady state is every 15 seconds. That's typically how we see these used. There is transient, which is up to 256 readings a second. If you're trying to figure out why you keep breaking pipes near a pump station or something like that, best thing about these, you can move them around. You can use them wherever you want for a while. So you go plug this thing in next to that pump station, run the pump station, have this thing in transient mode, and you can actually watch a surge occur and see how bad the pressure spikes are during a water hammer event. And so that's kind of what that's used for. Then you can go put it back in steady state mode, put it, in your distribution line somewhere, and just have it in observance mode. And what that is you give it a low and high set point. You can say my pressure is ever below 15 psi, send me an alert. If it's above 60 psi, send me an alert. And so it'll email or it'll text you, and it'll say you've got a pressure. And so getting back to the leak detection thing, this is a lot cheaper, easier version. Is if you ever have a big pressure drop, you've likely got a pipe break. So these are good use for that. They're also good for hydraulic modeling. They'll collect data for years. on the system. As I mentioned, you can move these around. They're really versatile, so you can put them in a roadway, in a bulk can. You can put them in a meter box. You can put them in air leaves. You can put them a lot of people have been putting them on their, we mentioned, PRVs earlier, putting them right in their control valves. That little threaded connection will go right into a port of a control valve. So if you've got a remote station where you don't really want to run power and SCADA out there, just put a couple of these guys in there and you can get an inlet pressure reading and outlet pressure reading in real time. You can also hook them to a tank. You can see that one hooked up to an altitude valve there, but you can have these things run in feet. I've seen a few different areas in Oregon using them for that. So rather than measuring PSI, you're measuring feet. And so if you got a level of the tank reading that you consistently know what's going on, it'll send you an alert if it's ever low or high. The last thing I'll leave you guys with today is our smart hydrant. So this is Mueller's newest release. And really it's everything that we've looked at on the last probably half of this presentation. So the DX leak detection. And so the DX leak detection was those pumper nozzle nodes that you can add to hydrants and they'll monitor for leaks for you 24/7. There's also the remote pressure monitoring that I showed you guys, that little black thing. So what we thought is, these are both cool technologies. What if we just build them right into a fire hydrant? And so that's what we've done. And so there's a smart hydrant for wet barrel and for dry barrel. So obviously you guys are probably looking at dry barrels. We can purchase these from Mueller brand new, or there's retrofit kits. So the leak detection node, as you can imagine, is really easy. You just unthread your pumper nozzle, replace it with the leak detection node, swipe it with a magnet. It's now looking for leaks. The pressure monitoring, if you buy the new hydrant, it's already in there. But the retro kit, you're going to replace the bonnet and the inner stem. So the very bottom of your stem is going to have the pressure monitor. That's actually going to Bluetooth up to the bonnet, and built into your bonnet is going to be batteries, GPS, cell, all the things we've talked about. And so this is really everything we've talked about here. If you're interested in it, just go to smarthydrant.com, check it out. Technology. So that is all I had for you guys today. We looked at non-revenue water from a few different perspectives, ways you can reduce it. So we looked at couplings. What kind of coupling is a good one to get? Pressure management. Maybe just reduce your guys' pressure at night. Put in some DMAs. Give you guys some more control of your brakes that way. We also looked at using e-pulse to go around and find how worn out your pipes are. Make better decisions on which pipe to replace, which pipe to leave alone. And then last we looked at active leakage. So the DX nodes and the pressure monitoring, and just ways to look at your system full time and be able to start building a picture of what's going on. Instead of just being reactive to situations as they occur, there is now technology that you can 24/7 be looking at your system sitting at a desk, and only roll out trucks when you need to. So that's all I have for you guys today, and be happy to take any questions. Definitely reach out if you're interested in any of this.